capacitor. Let's first make some analogy. Let's say that we have some tank, and inside the tank we are going to put some water. And now with that tank and with that water inside the tank, we have the system which has some potential energy. And later we can use that potential energy to do some work. With capacitor, we have the similar situation. The capacitor, we have two plates, metal plates, conductors. They are both neutral. There is no charge on it. But what we are going to do, we are going to take, let's say, from the bottom plate, we are going to take, let's say, negative charge and put on bottom plate, and we are going to repeat that process. And now what we have, we have the two plates. Bottom plate actually is with positive charge, and top plate is with negative charge. And of course between them now we have electric field. And definition of capacitor actually is amount of charge on plates divided by potential difference between the plates, and unit is farad. And farad is quite big unit. This means if with potential difference of 1 volt, we have the amount of charge on 1 coulomb on each plate. And this is really big unit, and usually we have the capacitors which are much smaller. Usually you have the big, for example, you have the big capacitor, for example, inside the power supply. They are for filtering, voltage. Or for example, you have the big capacitors in amplifiers, and yeah, that's it. So the capacitance actually measures the ability of system to store the charge. And yes, so let's see what is the voltage between the plates. First, yeah, we know that for for the single big plate, the electric field is given by this formula. And in this situation, electric field between the plates inside the capacitor, it's given by this formula here. So let's use that. The potential difference, we can we can write the integral of electric field dr, but we don't have to do that because electric field inside here is constant, so we can write that it's equal to this expression here. And now what we are going to do, basically what I did here, actually I just replaced some for example this is the expression for surface amount of density of electric charge. And this is quite trivial, and at the end you will get this formula here. So this is the formula for for capacitance of some capacitor. So basically it's pretty much straightforward, you know, and it's quite logical, you know. Basically what says, if you have the bigger plates, you know, bigger area on the of the plates, you know, your system will be will have the better ability to hold more charge on it, you know. It's quite logical. So what else we can say about the capacitor? That's the amount of energy that can store. So let's say, okay, so let's say that we have two plates, right? We have a capacitor, and let's say we have the on top plate we have positive charge, on bottom plate we have some amount of negative charge, and work. And let's say that we have transfer some small amount of charge from, let's say, bottom plate to top plate, some delta Q. So then we can write that that small amount of work that is done, it's equal to, okay, that small amount of charge that we transfer times the voltage at that moment between the plates. And the voltage between the plates of that moment, it's at that time, is equal to amount of charge that we have on the plates divided by W. The fuck I'm doing? Sorry, it's divided by capacitance. Yeah. So the voltage, the voltage between plates at that moment, actually we can write as the amount of charge that we already have between plates divided by capacitance. And you know, this is the we can now write the integral, and we can write from time 0 to some, I don't know, time t, doesn't matter. And what we can do, yeah, we can write, so we can write like this, delta Q. But since this is a constant, we can pull out that constant, and we can write C over the time t, that doesn't matter. So Q, delta Q, and the integral of that, actually the is equal to 1 over C, and this is Q divided by 2. So yeah, this is the work which is stored, actually the energy which is stored between the plates of capacitor.